Alright, we're going to start with page 16, summarizing distributions for approximately symmetric distributions. We talked about needing the interquartile range and median for skewed distributions. Now we'll talk about what's appropriate for approximately symmetric distributions. This is a perfectly symmetric distribution. It's actually called the normal probability distribution. We're going to learn a whole lot about that in Chapter 5. But basically what you need to know is it's unimodal and it's symmetric. It's the bell curve. You've heard of it, I'm sure, and used it before. Also, a uniform probability distribution is just a perfectly uniform distribution. No variation at all. It's perfect. These two are too perfect, so real data would be very unusual to look exactly this perfect, but they are good models, and a lot of times we just use models that look perfect and to represent data or to compare actual data to. But regardless, for the sake of finding the mean, we're going to think about these types of distributions. Think about this. What relationship would you expect between the mean and the median for symmetric data? So the median is the middle data value right here, right? So median. And what about the average or the mean data value? Well, that's going to be right in the exact same place. With the mean, you have the same, value of space before and after the middle, and so it's going to be the same. Median is the same as the mean for perfectly symmetric distributions. This distribution uniform, it is also perfectly symmetric, so if we found the midpoint here between 0 and 1, this would be the median and the mean as well. How would we find the mean and the data set? What techniques are we going to use to do that? Well, the mean, just first of all, think it's average. So when we're speaking, a lot of times we will just say average. And what we want to do is we actually want to sum up all the x values, all the data values, and that's how we'll show that, the sum of all the x variables, and we'll divide by the total number of values. So what are we doing? We're adding up all values, all the data values, and we're dividing by total number of values. Your data set size, and the symbol we're going to use for this is x bar. Your calculator uses x bar, variable is x. Your textbook, however, likes to use y bar, so they use the primary variable as y, which is fine. It's the same setup. It's the sum of all the y values divided by n. On your calculator, you may have seen it before. Well, I know you've seen it before. I don't know if you paid any attention to it, but when I still have the data in there from the girls and boys, so you can actually get the mean on your calculator. You do not have to calculate it by hand. And we're going to go to Stat Calc. So hit Stat Calc, and number 1 variable stats, actually the same place that we got our 5-number summary. I'm going to go ahead and do list 1 first. This is where you'll leave the frequency list blank because you don't have a frequency list. And look at that very first thing, x bar. 21.63636 and so forth. As far as decimal points go in here, usually you would want 1 or 2 more decimal points than the original data. In this case, the original data was the times for the boys and the girls, so I would probably report this mean as 21.6, and this would have been the boy data. So when you're doing 1 variable stats to get your 5-number summary, you can also get the mean. And you would do a similar thing to get the girl values, or the value of the mean for any list that you have. Alright, let's go on to page 17. And I'm going to start this one. I have another video that finishes page 17, but I've got to get this started here. Actually, to look like the other video. I don't know, I can't remember now what the colors were in here, but this next page or so is intended to give you a geometric interpretation of how the mean is different than the median. If this were a color copy, this would look all nice. It's not a color copy, so we're going to have to mark this up. The mode of the distribution, well, that's, what data value occurs the most often. I'm going to make that red, and that's going to be at the peak of these. So you have two different distributions here. I hope you can see them. This one that I'm marking on now is kind of approximately symmetric, and then this one that's kind of made with the dotted lines is skewed right. So we want to look at the modes of each one of those. The mode here occurs the most often, so there's your mode there. The median is the middle value, and in this that looks approximately symmetric, it is actually a little heavier on the right than it is on the left. I'm going to do the median in this blue. Hopefully you can see these colors pretty good. So the next line is going to be the median, and I'm going to just color that in kind of dark. Now, I don't know if you can see this, if you can look closely on yours, but there's actually a vertical bar like these two. There's one right in here, and that's also that's the median of this distribution. The median is right here. So actually the two medians are pretty close in these two distributions. One of them is there, and the other one is right there. Okay? The mean is the interesting piece of this. So the mean, well, I'm going to do it in green. The mean of this almost symmetric distribution is pretty close to the median. It's just a little to the right of the median, and that's because the distribution is a little bit heavier on the right-hand side than it is on the left. But on this severely skewed distribution, the mean is way out here. Now, it may not be quite this far out on every skewed distribution, but what is happening to the mean is these data values that fall way out here and probably go beyond that, they're pulling that average value size, or the mean average value size, way to the right. So on a skewed distribution, the mode is going to be where the peak is. On a right skewed distribution, the mode's going to be on the left side here. The median is a little off to the right, and then the mean is going to be further to the right. If this were a left skewed distribution, you would have the mode here, the median there, and then the mean would be further to the left because it's pulling it away. Alright, the next video is actually one that I made in a prior year, and it picks up basically right here on the page, so I'm going to leave the rest of this to that video.